Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem allocate books. Now this is a very famous question. This has been asked in Google a lot of times. This is asked in a lot of coding rounds. Yes, they just tweak this question into some other form and you can see this question in a lot of coding rounds. So what does this problem state? The problem states you'll be given 4n books, okay, and every book will have certain number of pages. Like the first book over here has 12 pages. The second book has 34, the third book has 67, the fourth book has 90 pages. And you'll be given students. Over here we can see we are given couple of students. Your task will be to allocate these books to couple of students such that the maximum number of pages allocated to a student is minimum. What does that mean? We're going to come to that. So let's assume there are two, like they're given couple of students, right? This is student 1, this is student 2. What is the allocation that you can do? So before doing the allocation, let's look at the conditions that you have to maintain while doing the allocations. First condition states a book will be allocated to one student only. Like if this book has 12 pages, you cannot do this. Hey, first student takes 6 pages, second student takes 6 pages. No, this is not allowed. If you are taking a book and you're allocating it, you have to either allocate 12 to this or either you have to allocate 12 to this. You cannot split it. So that's the first condition that you have to keep in mind while allocating. What's the next condition? Each student must get a minimum of one book. That means you cannot do an allocation where you say, hey, student 2, take 12, 34, 67, 90. And you're saying, student 1, I'm not going to give you any book. That's not allowed. Okay. You must at least give one book to each of the students. So this kind of allocation is not allowed. Let's come to the next condition. Allotment should be in contiguous order. What does that mean? Basically, you cannot do an allocation like, hey, student 1, take 12, take 67, and you're saying, student 2, you're going to take 34 and 90. This is a wrong allocation because allotment should be done in a contiguous order. And I say contiguous order, 12, 67, they're not contiguous books. So this allotment is not done because 12 and 67 has a 34 in between. Hence, 12 and 67 books are not in contiguous fashion. So this kind of allotment is also not possible. So you have to just make sure that these three conditions are kept while you're allocating the books. So you've understood how to allocate by keeping these conditions. Now I'll talk about this condition, which is our question. So once you've understood the condition, let's try to allocate. Can I say student 1, you're going to take 12. Can I say student 2, you're going to take 34, 67, 90. This is one of the possible allocations that you can do. What is the other possible allocation that you can do? You can definitely try this allocation. 12, 34. You're saying student 1, you're going to take 12 and 34. And I'm going to say student 2, you're going to take 67 and a 90. That's one more possible allocation that I can do. What is the other possible allocation I can? I can say student 1, you're going to take 12, 34, 67. And I'm going to say student 2, you take something as 90. Okay. So these are the three possible allocations that I can do if I keep these conditions in my mind. Now, what does the question say? Maximum number of pages allocated rather. So over here, can I say the student 1 gets 12 pages? Can I say that? And can I say the student 2 is getting the summation of this, that's 191 pages. So the maximum allocation in this case is 191. Yes, the maximum allocation in this case is 191 because student 1 gets 12 pages, student 2 gets 191 pages if you add them up. So the maximum of allocation is 191 pages. So if I look at this allocation, this is nothing but 46 and this allocation is 64 plus 90, that's 157. So out of these two allocations, which is the maximum? Obviously something like 157 is the maximum, correct? Let's check out this allocation. So if I check the student 1's allocation and if I add this, I'll get something as 113. And the student 2 has 90. Yes, has 90 pages as allocation. So what is the maximum among them? 113. Now the question stated maximum number of pages allocated is minimum. Which of the condition has maximum pages? This is maximum. And out of these, which allocation has minimal? I can say this is my answer which has minimal. 113 is minimal. Hence, this is the allocation that I require. Yes, and you need to print this 113, the maximums, minimum. You have to print this. That is the question. You have to allocate the books in such a way that the maximum number of pages allocated is as small as possible. So I hope you have understood the question. Now, what is the first solution that comes to your mind? It's generally recursion that comes to your brain, isn't it? Basically, you're going to try to partition, whether you'll partition here, or whether you'll partition here, or whether you'll partition here. Basically, you're thinking of a recursive solution where you'll try to partition. But again, whenever you try recursion, the solutions are generally exponential in nature. And if you try writing a recursive solution to it, you'll get an exponential complexity. And even if you apply dynamic programming to it, you will end up getting a big of n square solution. I'll not be discussing this over here because this is not the most optimal solution. And even if this question is asked to you in an interview, I'll recommend don't tell the solution because it's going to kill a lot of time. Don't even tell the solution. Directly jump to the binary search because explaining the binary search solution is going to take some time in the interview. So don't tell him this recursion and then a dynamic programming, then n square, because it's going to kill your time. And after that, you will not have a time to optimize this further. So directly if this question is asked to you in an interview, tell them the binary search solution. Okay. So before moving on to the next part of the video, let me tell you about the sponsors of this video. If you are looking for interview preparation, if you want to become a DSA champ, or if you are wanting to become a good problem solver, I will highly recommend that you should go and check out Unacademy. Now, because Unacademy along with Code Chef is currently giving you a lot of free classes, and all these free classes can be accessed by just creating your account or logging in. Yes, and if you use the take you forward coupon code, you can unlock all the free classes. And if you're using mobile, you have to download the app, and over there you have to again sign up using the coupon code take you forward. Also, why to take these classes? Because these classes are taken up by top educators of India who are working at Google, Facebook, LinkedIn, and a lot of people are 7-star at Code Chef, Red Hat, Code Forces. So these are top-notch instructors. So you're gonna be taught by the best among the best. So if you have checked out their free live classes and you're interested in taking up a subscription model, you can definitely check out the subscription model, because if you take up a subscription model, you'll be able to access all their previous classes, all their upcoming courses, and all their current courses. And there are a couple of courses that are going to launch on 8th of June. I'll be leaving those link in the description below. Those are specifically for beginners as well as intermediate level programmers. So guys, go check it out, and if you feel like taking it, definitely try it out. Now, what will be the most optimal solution to this allocate books problem? That will be binary search. Now, why? If you have seen my previous videos, you would have got an idea that binary search can be implemented on a search space. If you can figure out the search space, you can actually implement the binary search on this search space. So I need to realize what can be this minimal answer. What can be the minimal answer? If I ask you, what is the minimal answer possible, right? And if I ask you, what is the maximal answer possible? If I ask you that, what's the minimal answer possible and what is the maximum answer possible to this question? And then I can say, this is going to be my search space. Okay, let's now think in terms of all the test cases. Can I say, if I take a test case like this, where the array is like 12, 12, 12, 12, okay, and the number of students is 4. Now, what will be the answer of allocation? Can I say I'll be allocating like 12, 12, 12, 12. So everyone's summation of pages will actually be 12, 12, 12, 12. So the maximum of them is actually 12, and that's the minimal possible. So can I say the minimal, whatever the answer at minimum can be the minimal value of this. Hence, at the worst case, the minimal answer can be 12. It cannot go beyond that. I hope you have understood that, right? Now, what will be the highest answer? Let's figure that out. Now, can I say the highest answer? If I take an example of array to be, let's imagine it's 10, 20, and 30, and I'm giving you the number of student as 1. What will be the highest answer? You're going to allocate everything to the student. There's no other option. So that's basically 10, 20, 30. And if you sum them up, you'll get 60. So can I say, at the worst case, the maximum answer that a combination can generate is the summation of all these guys. I hope you understand this. So can I say over here, if I just think that student is 1, yes, student is 2, I know, but at maximum, just imagine what will be the maximum answer of allocation. I mean, summation of this, that's 203. I know one thing, the answer that I found out was 113, if you remember. That is going to lie between 12 and between 203. So I have defined my search space. Now I'm going to think of binary search. Let's see if we can implement binary search on this. So the answer will definitely lie between 12 and 203. So let's assume this to be low. Let's assume this to be high. Okay. So I have made sure that this is low and this is high. What will be the middle? Middle will be 107. 12 plus 203 divided by 2 will definitely give you 107. So that's your middle. Okay. So figure out the middle. Now what you'll try to do is you'll take these pages and try to allocate to 2 students such that you do not end up allocating more than 107 pages to anyone because you want 107 to be your answer, right? So what you'll do is let's take the student 1. You say 12. Okay. Give it to student 1. It still has not exceeded 107. You take 34. Give it to student 1. It still has not exceeded 107. You take 67. But can you give it to student 1? Because if you add 67, student 1 will actually have 113 pages. But you cannot exceed 107. Hence, you will not allocate this 67 to student 1. Rather, you will allocate it to student 2. So take the 67 and allocate it to student 2. Now, can you allocate this 90 to student 2? Can you? Because the moment you add 90, it exceeds 107. So you're not allowed to allocate 90. What do? You'll take this 90 and allocate it to student 3. Yes, you allocate it to student 3. So I was able to allocate all the books. But I figured out that I actually, by keeping a maximum barrier of 107, I ended up allocating books to 3 students. But the question clearly stated, I only have 2 students. So you cannot allocate books to 2 students by keeping a barrier of 107. So you need to increase the barrier. Obviously, by keeping 107 as a barrier, you could not allocate. So by keeping 106, by keeping 100, by keeping 13, you will also not be able to. So can I say this portion can never have my answer? And my answer will lie somewhere between 108 to 203. This is why binary search can be implemented, because I know if by keeping a certain barrier, I could not, the entire left side automatically gets eliminated. Hence, we will do this. The search space is now this. Let's figure out the middle. So if you figure out the middle, you'll get 108 plus 203 divided by half. That's nothing but 155. So you get the middle as 155. Let's try to allocate. So the student 1 takes this 12. The student 2 takes this 34. The student 3 takes this 67. Still allowed. The student 1, when it tries to take this 90, this barrier is crossed. Hence, you cannot take this 90. Hence, you will take this and say student 2 to take this 90. So I can see by keeping a maximum barrier of 155, I could allocate to couple of students. Yes, I could allocate to couple of students. And if I can allocate to couple of students, can I say 155 can be one of my possible answers? Yes, I can definitely say 155 is one of my possible answers. So, what is the question stating? You need to figure out the minimal. So, which portion will get eliminated? 156 will also give you, 157 will also give you, but you need it to be minimal. Hence, the search space, the right search space will decrease. And now you'll do a binary search from 108 to 154. I hope you're getting it. So now you have reduced your search space to 108 and 154. So the middle this time will be 131. So again, try to distribute books by keeping this barrier of 131. Take 12, distribute to person 1. Take 34, distribute it to person 1. Take 67, distribute it to person 1, because still the barrier of 131 has not been crossed. But the moment you try to distribute this 30 to this person 1, the barrier will be crossed. Hence, this 90 gets distributed to person 2. So again, I can see by taking a 131, I was able to distribute or allocate books to not more than 2 students. That means 131 is a valid barrier. Hence, this will reduce to 131. And I'll try to reduce it because I want minimal. So this portion will get eliminated and my search space will be from 108 to 130. So let's do that. So let's try to find out the middle of this. So the middle of this will be 119. Let's keep this as a barrier and try to distribute. So the first student will get the 12, then it will get the 34, then it will get the 67, and the moment it tries to take 90, it cannot. So the second student will definitely take 90. So again, by keeping 119, I could distribute to not more than 2 students. Not more than 2 students. So this is a very valid barrier. So what I'll do is I'll reduce the search space this time to 108 to 118. Now since I figured out the answer at 119, I'll write it over here and the search space will reduce to this much. Now the middle of this is nothing but 113. Yes. And again, try to keep this as a barrier. And if you try to keep this as a barrier, you can take 12, you can definitely take 34, and you can take something as 67. That's possible. And in the second, you can take this 90. So again, by keeping a barrier of 113, I was able to distribute books. Yes, I was able to. Hence, my answer gets reduced to 113. My answer is getting reduced. So obviously, I'll not be requiring this. So the right half will be eliminated. So let's eliminate. So now my search space reduces to 108 to 112. What will be the middle of this? 110. So let's try to keep this as a barrier and try to allocate books. So the student 1 will take 12, 34, but it cannot take 67 because adding 67 will cross the barrier of 110. So student 2 will take 67, but can it take 90? No, because the barrier will be crossed. Hence, student 3 will take the 90. Again, by taking 110, it was not possible to allocate in the given number of students. Not possible. Hence, 108, 109, none of them is possible. So the search space reduces to somewhere 111 to 112. Remember, the answer will not be changed because we have minimized this right portion and this is standing at 113. So now the middle of this and this is nothing but 111. So let's try to keep this as a barrier and let's try. Student 1 will take 12, 34, will not be able to take 67. This guy will take 67, this guy will take 90. Again, by keeping a barrier of this, it's not possible. Yes, that's not possible. So this left half will get eliminated and the search space will be trimmed down to 112 to 112. Yes. So your low will be 112, your high will be 112 because this is the new search space. And what will be the middle? The middle will also be 112. So if I try to allocate books by keeping this as a barrier, will I be? So person 1 will take something as 12, then 34, but it will not be able to take 67 because 112 will be crossed. Person 2 will take 67, person 3 will take 90. Again, by keeping a barrier of 103, I was not able to distribute in 2 students. Hence, this is also not possible. So this guy will go ahead and the low will become 113. What happens in binary search, right? So over here we can see this is the new search space. And what I can see is the search space, the low is crossing high. And that's when the binary search ends. So what I can say is if low has crossed high, that means from 113, 114, these barriers were achieved. You can keep a maximum allocation of these guys. Yes, you can maximum allocate these guys. So on, you can allocate these guys. But if high is at 112, 111, 110, beyond this guys, you cannot. So this is the break point. Over here you can, and you wanted the minimal of this allocation. So the minimal is 113. That's your answer. This is how you're going to do a binary search to figure out the answer. Now, we know we have to write a binary search. So we know low was nothing but the minimal in the array and high was nothing but the sum of the array that we took. And initially, let's keep resultant, which was the answer that we are storing as -1. Now, we know one thing, the binary search, this is the condition. Now, in starting, what do we write? We write something as mid equal to low plus high by 2. That's very obvious. This is what I write. Low plus high by 2. Now, what were you checking? can this be possible? Like, can the allocation by is if the allocation is possible? Yes, if the allocation is possible by keeping the barrier of mid, if by keeping the barrier of mid, if the allocation is possible, what does that mean? That means I'm saying this mid can be my answer. Hence, I'll update res by mid and I'll reduce the right half. Yes, I'll come to the left because I want to make it minimal. So high will become mid minus 1. High will become mid minus 1. But if this allocation is not possible, then what will happen? Then I will have to reduce the left half because keeping a smaller barrier was not possible. I have to increase the barrier. I have to move. Hence, low will go to the right. That's low equal to mid plus 1. And this is how the binary search will look like. And about allocation is possible. Let's check it out. If you are given a value, how will you check in an array if an allocation is possible or not? Let's check that out. So let's assume you are writing a boolean is possible function which takes a barrier and it tells you if it is possible to allocate these books among these students by keeping a barrier of this. It returns true if it is and it returns false if it is not possible. So what we will do is we will take allocated students. What is the initial student? Because initially we start with 1 students. So initially the allocated student is 1. As of now we have just started with 1 student. And what I can say is the number of pages that I've allocated to the students is as of now 0. Because currently we have first student and I haven't allocated it. I'll take 12, then I'll allocate it. Then I'll take 34, then I'll allocate it. I'll take 67, then I'll allocate it. But as of now I haven't. So in order to take 12, 34, I will have to iterate from 0 till n, correct? And I will have to go like this. Now what do I need to check? I just need to check if first of all, just think of this condition. If this barrier is somewhere like 10, okay. If the barrier is 10, will you be able to allocate 12? Not possible. Even if you take the second student or the third student, can you allocate this 12? Obviously not. Because a book has to be allocated to an individual student. And in order to do that, the barrier should be at least greater than the individual elements, correct? So if by chance your individual array element goes beyond barrier, that means that book cannot be allocated. Hence, I will say by keeping this barrier, I will not be able to allocate. Hence, you'll return false. But what if it is inside the barrier? Then you simply check. What happens if I've currently student 1 has 0 pages? So pages plus array of I, if this crosses barrier. As of now it is not. As of now pages is 0. 0 plus 12, if you take a barrier let's say of 110, it doesn't crosses. If it crosses, we are going to do something. But if it doesn't crosses, we are going to add it to our student. Yes. Let's say student, please add this array of I to yourself. Right? We're going to tell them, please add it to yourself. And this is where my for loop will end. But what about if it crosses? Let's say for the student 1, you're adding 12, then you added 34. But if you're wanting to add 67, it crosses the barrier 110. Then what will you do if it crosses? Then you'll say, hey, new student, come in. So I'll say new student will come. So that's plus equal to 1. You'll say new student will be there. And that new student pages will be 0. But he will take this array of I because this array of I cannot go to 1 any further. So this guy will take this array of I. Yes, so let's take this array of I to this guy. You can keep on doing this. And once this for loop gets executed, you can actually say if this allocated student is greater than 2, assume this to be k, is greater than 2, then I can say I was not able to allocate. Or else you will say I was able to allocate. So this comes over here, right? This portion will come over after for loop. So over here, once you have written this, you can definitely end the function which starts from here. This is how you're going to check if it is possible to allocate by keeping this barrier. This is how the code will look like. What's the complexity of this code? Big of n. Simple, because you're running a for loop. That's a big of n. So if you remember the structure of the code, It was a binary search. Inside that, you call this is possible function. So the binary search takes logarithmic of n, right? And this is the is possible function that you called. What is this is possible function taking? Big O of n. So I can say the complexity is log n into big O of n. That's the time complexity. Are we using any external space? Are we using any external space? No. Hence, the space complexity is big O of 1 for this particular solution. So guys, this was my first whiteboard video, and you can see I'm shooting at 3 o'clock in the night. So please drop in a comment, and if you have understood the approach, make sure you like it. And if you're new to our channel, do consider subscribing to us. Bye bye, take care.
Whenever your heart is broken, don't ever forget.